Hello guys, I hope you are feeling well. I'm going today to talk about the point of inflection. What is the meaning of point of inflection? Here, let f be a function that is continuous on an open interval and let c be a point in the interval. If the graph of a function f has a tangent line at this point, be careful. Look here, that is the first thing. To be inflection point, it has a tangent line. Okay, at this point, the function has a tangent line at this point. Then, this point of inflection of the graph of f, if the concavity of function changes from upward to downward, or downward to upward at this point. As I'll show you now, here, the concavity of this function upward at this point, which is a point of inflection, change it to be downward. Okay, at this point, the function has what? At this point, the function has a tangent at this point. Okay, but here, at the point of inflection, or the point of inflection is what? Point at which the function has a tangent line. Okay, the second step, the concavity of the function changes from upward to downward or downward to upward. Okay, here as you see at this point it has what? A tangent. It has a tangent line. And at this point the concavity of the function changes from downward to what? Upward. Okay? Here at this point, which is a point of inflection y, at which it has a tangent line and the concavity of the function changes from upward to downward. Okay? We note that. Look here, the concavity of f changes at the point of what? The inflection, at the point of inflection. And also, the graph crosses its tangent line. As you see here, the graph crosses its tangent line. Look, cross here. And here, cross. Cross what? The graph. Cross what? The graph, as you see. Okay? Now, I'd like to tell you also or explain or state the theorem of 4.8, point of inflection. What is the properties of a point of inflection? Here, if the coordinate c and f at c is a point of inflection of a graph of f, then either the second derivative at this point equals 0 or the second derivative does not exist at x equal c. It means, look here, we have some properties of the point of inflection. The first one, the graph has a tangent line at it. The second one, the concavity of the function changes from upward to downward or downward to upward. At the point of inflection, okay, the second derivative equals 0 or does not exist. Okay? But be careful. Here, at the point of inflection, we have all of these properties. But if the second derivative equals 0 or does not exist, it means at this point we have point of inflection? No. It doesn't mean this one. The concavity must be changed. The graph has tangent line. Okay? Let's show you how to solve the problem on this topic. Here, as you see, find the point of inflection and discuss the concavity of the function, the concavity of the graph of the function. How to solve this one? Please, it's so trivial, but focus with me, okay? How I think of the solution. The first step, I have to say what is the domain of the function. This domain all real, all real. That's right. Because at the point of inflection, the function must be continuous, must be defined, it has tangent line. Okay? The second derivative equals 0 and the concavity changes. Okay, what is the first step? Find the first derivative, which is multiply, it will be 2x, x to power 3 plus 6x to power 2. Okay, to find the point of inflection. Second step, because the point of inflection occur at x such that the second derivative equals 0 or does not exist. Occur at this one, but it doesn't mean when add the value of x at which the second derivative equals 0 or does not exist, it means we have a point of inflection. Okay, find the second derivative, which is 6x squared plus 12x. Clear up to now? Then find where the second derivative equals 0 or does not exist. Since the function here polynomial, we find the value of x where the second derivative equal what? 0. There is no values of x at which the second derivative does not exist. At equal 0. I find the values of x such that the second derivative equal what? 0. Plus 12x equal what? 0. By factorizing, I will take 6x as a common factor. It will be x plus 2 equal what? 0. Implies x equals 0 or x equal what? Negative 2. It is possible to be these two value of x possible to be point of inflection, but I'm not making sure how to know if the concavity of the function changes around each one of them. It will has what? It will be inflection point. So in this case, I'll use, since I will discuss the concavity, I will use second derivative test. Second what? Derivative test. Look with me here. Second what? Second derivative test. Here I will write here 0 and here what? 2 or negative 2 first, because from the smallest to the great. Negative 2. I'm sorry. Negative 2 and here what? 0. Then here that is for second derivative test. Negative infinity here and here what? Infinity. What is the test value smaller than 8, negative 3? Here I will take negative 1. Here I will take 1. Then replace in what? In the second derivative. I care about the sign. Negative 3, it will be here negative, and here negative, it will be positive. So it will concave what? Up. Concave what? Up. If I replace negative 1, it will be negative, and here positive, it will be negative. So it will concave what? Down. If the second derivative more than 0, it will be concave up. Less than 0, concave down. Okay, at 1, I replace, it will be positive also. It means concave what? Up. Miss here, since at negative 2, the concavity change from concave upward, then concave downward, I have what? Inflection. Inflection, okay? And here, since the concavity of the function at 0 changes from concave downward to upward, it is what? Inflection point. Okay, inflection point, the values of x at which the second derivative equals 0 or does not exist, and the behavior of the function changes from a concave upward to downward. Okay? Now, he asked me to tell him about the interval. In this case, look here, I write in different color. The function f is concave upward where? On which interval? I have two intervals. The first one, negative infinity, is this one, and this one, it will be negative infinity and negative 2. And, okay, 0 and what? Infinity. Clear? Concave, F is concave downward on which interval? Negative 2 and 0. Negative 2 and 0. But I'm not talking about only the concavity. I'm talking about what else? The inflection point. Here, point, it means x and y. يبقى inflection F has inflection, okay, point at what? At, look here, negative 2 and F negative 2. F negative 2, it means replace. To find the y coordinate, I have to replace in the original, what? In the original function. It will be what? What is the value? Here it will be, I'm so sorry. I solve it, but I search. Okay, no problem. I correct with you, no problem. Okay. Here I replace by negative 2, it will be 16, divide 2, it will be 8 minus negative 8. Okay? And what else? As the other one, 0. Replaced by 0 in the function, it will be 0 and 0. So the function has inflection point at what and what? At negative 2, negative 8, and 0 and 0. I hope you understand, and if you don't understand this video, you can ask me in the live session. In what? In the live session. It is negative infinity and negative 2 in concave upward, downward, and 0 infinity. Okay, inflection point, I told you at which point? At 0, negative 2, negative 8, and 0 and 0. I hope you understand well, and if you don't understand any question, prepare all of your question in the live session, okay? Okay. Now, do you have any question here? Do you have, inshallah, prepare all of your question. Now, let's see the others problem. Okay, let's see the others what?